Welcome back to our YouTube channel. In this video, we are going to discuss about merge intervals, where we are initially given with an array called intervals, and each index contains another list which will contain again start and end, which signifies the start of the interval and end of the interval. And we have to match all the overlapping intervals, and at the end we are going to return the non-overlapping intervals that covers all the intervals in the input. And if we see at the example, in this example we are given with a list of lists, and every start element refers to the starting of the interval, and every end element refers to the ending of the interval, and we have to return the non-overlapping intervals, which means we have to merge. And let's draw this example in the line form. We're going to see 1 and 3, 2 and 6 will be something like this, 8 and 10, and 15 and 18. If you could see here, this is the overlapping region. Therefore, we're gonna make sure this should be measured. 1 and 6 will be now an single interval rather than 1 to 3 and 2 to 6. And another is this. You can see that there is no interval, right? There is no intersection. And here also the same thing, there is no intersection. Therefore, at the end, we're gonna return our final answer as 1, 6, 8, 10, and 15, 18. And this will be our output. And let's look at another example. In this example, if you see here, the 4, 7 would be something like this, and 1, 4 would be something like this. And if you can see that this single point is the point of contact, therefore our new intervals become 1, 7. Therefore we're going to return 1, 7. And if the intuition is clear, let's look at the brute force solution. When we know that two intervals can be merged, if we can know that if the start of one interval is lesser than or equal to the end of another interval. If you could see here, the start is 2 and the end is 3. 2 is lesser than or equal to 3, then it is the required condition that two intervals can be merged. Therefore, what we do is we're gonna just make sure that the minimum is 1, and among this, which is the maximum, 3 and 6. 6 is the max, right? Therefore we're gonna put 6, and at the same time we're gonna pop this out and insert this into the same list, and the remaining elements can be copied out. And we have to do the same thing again. If 8 is still lesser than or equal to 6, is it true? No. Again 15, no. Again no. Therefore we can see that none of the start is lesser than or equal to n. Therefore there are no intervals that are overlapping with each other, and this will be our final output. But if you can see here the complexity of this approach, we're gonna first identify, first we're gonna check for every element, each and every element, which takes a time complex of order of n square. Then if they are matching, if there is a match, if there is a condition exists, if the start is lesser than or equal to n, then we're gonna pop the both intervals. Again, if they pop, we're gonna slide the remaining intervals to the left, which takes another time complex of order of n. Again we're gonna insert it at any position, right? Like if we insert at the last, it's gonna take a less time complexity, but if it insert at anywhere, it's gonna take a much time complexity, right? Therefore this approach, order of n square plus order of n, again inserting overhead, we're going to have a huge time complexity required to solve this problem. And in order to solve it better, let's look at the better solution for this problem. Try to understand these type of interval problems in a most greedy way. The word greedy will strike concepts. One is sorting, and sometimes it is stack. And if you look at here, the example 1, the intervals are sorted again. So the 1 comes before 2, 2 comes before 8, 8 comes before 15. Done. This it is here it is sorted. Then what we could do is we're going to take a stack data structure, and initially we are at here. The stack is empty. Whenever the stack is empty, please put whatever you are at, and move forward. And when we are at here, we can see that 2 comma 6. We're gonna check if there is a stack. The stack is full, or sorry, the stack is having consisting of some elements 1 comma 3. Now our current element is 2 comma 6. We're gonna do the same check, like if the start is lesser than or equal to n, 2 is lesser than or equal to 3, then again we're gonna do the same condition. We're gonna replace this 3 with max of its n, which is 3, and its n, which is 6. Got it? What is the max of both, which is 6? Therefore we're gonna remove it and make it as 1 comma 6. Got it? And we are done with the current element. We're gonna move forward. We're gonna see if we at 8 comma 10, our start is 8 and the n present in the stack is 6, something like 6. Therefore the 8 is not lesser than or equal to 6. If it is not obeying the condition, then please push into the stack. Done. And I'm at the last list, and you're gonna see the same thing. 15 is not lesser than or equal to 8, right? Therefore we're gonna do the same thing, just push into the stack. And at the end we're gonna pop everything out, like 15 comma 18, 8 comma 10, and 1 comma 6, and this will be our output. Or we can simply return the stack itself, which is 1 comma 6, 8 comma 10, and 15 comma 18. Here first of all we're gonna sort the interval. After sorting, we're gonna take the stack data structure, which is empty first of all, and we're gonna start iterating for start comma n in intervals. Initially the stack is empty, right? If not stack, then stack dot append the list of start comma n. We'll go into the else block if there is a stack, like if there are elements in the stack. Then in that case we're going to check that if our start is lesser than or equal to the stack tops n, right? If it is so, then we're going to update the stack's elements, top element, which is max of stack of -191 comma our new n. Else we're going to do the same thing, stack dot append s comma e, when there are no overlaps. Therefore at the end we're going to just return the stack itself. And let's quickly run this. It's running fine, and we'll submit it. So it's also getting submitted correct. And let's discuss the time and space complexity. I'm gonna check that it's the same n log n, and the space here it's also order of n. It's taking a little bit of time. If you see here, the time complexity is same, the order of n log n. And let's see the space complexity. The space complexity is also order of n. And this is the case when we have non-overlapping intervals, when we end up pushing all the intervals into the stack. And if you really like this video, then please do like, share, and subscribe. Thank you.